Hello everyone, my name is Matthew Glenn and I'm a freelance math tutor, and today I'm going to be recording the second video in my introductory series on factoring, simplification, and the distributive property, with today's focus being on simplification, specifically simplifying expressions that use fractions, using those foundational skills of factoring that I discussed in the last video. So, without further ado, I hope you guys enjoy, and always remember, if you like this video, if you like my teaching style and would be interested in working with me, feel free to contact me and we can discuss a plan to help you or your child. Thank you all so much. I hope you enjoy the video. All right, everyone, we are going to get started with simplifying fractions. And simplifying fractions is a really useful technique to know in mathematics. It basically is the process of us taking some fraction which can be simplified or lowered to a smaller denominator while being the exact same number. And before we get started, let's look at an example just so we can visualize what that means. Let's look at 1/2 real quick. As we know, we could represent a whole as, say, a square, split into halves, and 1/2 would just be one of these two pieces of the square being filled in. Now, if we were to look at a different example, let's say 5/10, that would be the same as if you had that same exact square, but instead of splitting it into two pieces, we're going to split it into 10 pieces, which I'm going to write just as doing 5 slices this way and then cut down the middle to make 10. And of those 10 slices, we're going to fill in 5 of them. Notice how even though more spaces are filled in, they're each smaller spaces, and in total, it's the same as writing half of the box is filled in. Now, if you were given the option between these two, working with 1/2 would be a lot simpler than working with 5/10. And a lot of teachers use this so that we have our answers to questions in lowest terms, because this trains students when they're working with math to get things in the easiest way, or the easiest form to work with in larger problems. Now, how do we do this exactly? Well, let's look at 12/21. And I'm going to teach you all a skill which is really important, and that's being able to rewrite numbers in a way that still mathematically is sound and is equivalent, but works in a different way and works in a way where we can manipulate an expression. And what I mean by that is, let's say we're looking at 12. We know that 12 is the same as writing 3 times 4. And similarly, if we wanted, we could write 21 as 3 times 7. Mathematically, 3 times 4 is the same exact thing as 12, and 21 is the same thing as 3 times 7. Now, you might be asking, why would we do this? Well, we know through the multiplication of fractions that we could split this fraction in two. So that we write it like this: 3/3 multiplied by 4/7. Now, keep in mind, remember again, when we multiply it out, it'll still be 3 times 4 and 3 times 7. It's still going to go back to 12/21, but it's split up. It looks a lot different, right? So what we're going to do next is we're going to use a rule in mathematics, which says that if you divide any number by itself, in this case 3 divided by 3, which is what this fraction is saying, that will always be equal to 1. You could think about like if you split 3 apples between 3 people, each person gets 1 apple. And that's still going to be multiplied by 4/7. Now keep in mind, this is the same as what we had before, it's the same as each step. It just looks a lot different. And last but not least, we know that any number times 1 is just itself. And as such, we have 4/7. Now, if you compare this to the beginning, 12/21, this is the exact same number. However, 4/7 is what we would call the reduced form or the simplified form, which is what you would want to submit or work with if given the chance. Now, with that said, let's say you've been doing cancellations and simplifying for a while now. you might not need to write all of these steps. If you're just starting out, yes, write all of these steps. Not only will it show your teacher your thought process at each phase, but it'll also be a way of solidifying why we're able to do the things that we're doing in math, which will help you or your child way down the line when you're working with more complicated, like word problems, for instance. Now, with that said, if you have been working with these for a while and you feel really confident in your skills, uh, you could also write it like this, where you have 12/21. And I would still write this step, breaking it down to its factors. And then from here, we're not going to write these two steps. Instead, what we're going to do is just cross these guys out, the threes, because they're the shared factor. They're the shared thing that we can pull out from that fraction. And then we're just going to write what's left over, 4/7, which I just noticed I wrote that wrong. I wrote 4/4. There we go. And that's all you would need to write. I would expect that in probably 8th or ninth grade, you could probably transition to this form and your teacher would be just fine with that. Now, with that said, I told us that we could pull out a 3, which is mathematically true. And when you're working with other numbers, if you notice that they share a factor, you could easily just pull out that number and that works just fine. However, if you do that, there could still be shared factors left behind, and it might not be in a perfectly simplified form yet. You might have to keep pulling out factors. However, we can use something in math called a greatest common factor to simplify it to lowest terms all in one step, which is a really strong tool, especially when you're working with really big numbers. Now, first, I'm going to go into the definition of a greatest common factor, and it actually uses each one of its words in the definition. All it is the largest or greatest factor, which is shared between two numbers, or if you want to say it's a factor which is in common between two numbers. Now, with that said, how do we find the greatest common factor? Well, what we do is we look at a fraction, say 18 and 24, and we find all the factors of one of those numbers. I'm going to do 18. So if we found all the factors of 18, we're first going to write the identity, because that's the easiest one to forget, but it is really important. And then we're going to look at it. We see 18 is an even number, so it is divisible by 2. And 2 times 9 is equal to 18. Now we could use the divisibility rule for 3, which says that if the sum of a number's digits is a multiple of 3, then it's divisible by 3. And since 1 plus 8 is 9, which is a multiple of 3, we can say that 3 is a factor of 18. Now, a quick rule for dividing by 4. If you divide by 2 and the result that you get from it, in this case 9, is also divisible by 2, then the original number is divisible by 4. In this case, 9 is not divisible by 2, so we can just skip by 4. And the divisibility rule for 5 says if the number ends with a 5 or a 0 in the ones place, it's divisible by 5. In this case, 18 does not have that, so we know 5 doesn't work. And we could start up with 6 again, but then it starts repeating, since it would be 6 and 3, then 9 and 2. Which means we can stop here. Now that we have all these factors, we know one of them should be the greatest common factor. Either that or it's already simplified, which is really good. Now with that said, all we do is we start the biggest number and we try seeing if the other number is a multiple of it. So if we look 18 and then 18 plus 18 will end up being 36, which skips over 24, which means 18 is not a factor of 24. Now we're going to start with 9, the next biggest number. And we know that goes 9, 18, 27. It skips by 24 again, so it's not 9. And then we can look at 6. 6, 12, 18. Oh, and then we hit 24. And the cool part about this is you can count along and see 6 times what equals 24, which in this case is 1, 2, 3, 4. So in case it's a bigger number, I know most of us have our times tables memorized, but if it's a really big number or you don't have trouble remembering that one, you can always just count along. and get the equivalent. But I am getting off track. What we see here is that 6 is a common factor and is in fact the greatest common factor between 18 and 24. As such, we can rewrite this using the exact method that we did in the last slide. So we're going to rewrite 18 as 6 times a number. In this case, we know it's 3 times 6. And then we'll do the same with 24, which we already just said is 6 times 4. And I'm going to write out all the steps just because I want to be very particular. So we can split it up into 2 different fractions. And then we can set the first one, 6 divided by 6 will always be equal to 1. And then we're going to multiply it by 3/4. A number times 1 is itself, which means 18/24, even though it's a really messier fraction, it's just the same as 3/4. And if you see, it's simplified, no shared factors except for 1, and we're all good, simplified. So the last thing I'm going to do here is I'm going to use a larger one, in this case 28 and 42. And I'm going to scroll down a little bit, go right here. I'm going to write all the factors of 28 again, starting with the identity, and then we know it's divisible by 2, it is even. Now let's try doing the divisibility rule for 3 just to be sure. We know 2 plus 8 is 10. 10 is not a multiple of 3, which means 3 is not a factor of 28. The good news here is that since 3 is not a factor of 28, any multiple of 3 like 6 or 9 also will not be a factor of 28, which is very nice to know. But that said, let's see if we're divisible by 4. We already divided by 2, we got 14. And if we divide it by 2 a second time, we would get 7. And since it evenly divides, we can say 4 times 7 is 28. Now it doesn't end with a 5 or a 0, so it's not divisible by 5. And since 3 is not a factor of 28, 6 is not a factor of 28. So this is all that we have, which is really good. It might be a bigger number, but only 6 factors. So we're going to do the same thing. We'll start at 28, the largest factor, 28, and that goes to 56, which skips over 42. It does not work. And then let's try 14. We're going to count up 14, 28, and then last but not least, 42, which works, which means the greatest common factor, even though it's kind of a weird number, is just 42. So now we're going to do what we did above, even though it's with larger numbers, that is a-okay. We'll do 14 times 2 is equal to 28. And then we'll do 14 times 2, or 14 times 3 rather, is equal to 42. And I'll write all my steps out because I like being meticulous here. So we're going to split up the fraction and just multiply it by 2/3. And we know 14 divided by 14, even though it's a really big number compared to what we've been working with, all of that will always be equal to 1 divided by 2/3. And then that is of course going to just be equal to 2/3. Meaning this really gross fraction is just 2/3, which is a lot easier for us to work with, and it's a much lower number, which means it is well simplified. All right, with that said, now you guys know how you can factor any fraction. And next video, we're going to expand on this more with a tactic called cross-cancellation, which shows us how we can basically do the same process, but across many fractions being multiplied together. And we'll see more about that next time. Thanks so much.